Let's explore complex rational expressions. What is a complex rational expression? Here's an example of one. And we're told to simplify this. What is a complex rational expression? You see here that this expression, looks complex. The name is justified. And a complex rational expression is simply a quotient. You see these things here. Inside this quotient are rational expressions. These are sometimes called the inside rational expression. Let's use this phrase. And in a complex rational expression is simply any quotient that contains one or more inside rational expressions. What does it mean to simplify such a rational expression? It turns out that you can simplify a complex rational expression into an ordinary one. As we'll see. In fact, it turns out that this is equivalent to the ordinary rational expression x over the square of x plus 1. Turns out. How did we come up with this? Let's see. Now, there are two equally valid methods for doing this type of problem. Let's explore one of them. So here's our original rational expression, this complex rational expression, and we want to simplify it into an ordinary rational expression. Now, when we simplify a rational expression, we are coming up with one that is equivalent or equal to the original. With that in mind, we can use the fact that when we multiply by 1, let's write that in green, we don't change the value of our quotient. We want to multiply by 1 in a certain form. What we don't like here, what we would like to eliminate, are these denominators, these inside denominators. So what can I multiply by? Like this. This will be our 1. What is the something? Something over something is what we're multiplied by, so that after multiplying, these two inside denominators are eliminated. Well, the something has to be divisible by both of the denominators. What I recommend using is the LCD. The least common denominator of all the inside rational expressions. So this will be the least common multiple of the denominators x plus 1 and x. And we see that x plus 1 and x, these right here, are each prime, and the LCM is here, it turns out to be their product. So that's what we'll do. Let's write it all out. And what do we get? Let's show the steps. We have x times x plus 1 multiplied against this numerator. Let's put parentheses around the numerator. And the x times x plus 1 is multiplied against the whole denominator. Remember, you need to use parentheses. You really do. And now we are going to distribute. X times x plus 1 multiplied with the first term minus x times x plus 1 multiplied with the, here it's similar on here on the bottom. Now let's simplify. See that the common factors of x plus 1 cancel here, and we're left with x squared on the bottom. The common factors of x cancel, and we're left with x plus 1 times x minus 1. So now, we've rewritten it as an ordinary rational expression, right? At this step, there are no inside rational expressions. Now, we want to leave our final answer simplified. And we need to see if there are any common factors between the top and the bottom. So we need to simplify the top by distributing the x here, x squared plus x minus x squared. On the bottom, 2x squared plus 2x minus, let's FOIL x squared minus x plus x minus 1. The top reduces to just x. The bottom becomes minus x, and the positive x cancel. Remember, this minus 1 right here forces us to change all the signs when we distribute. So we get that, which is x over 2x squared. Let's fix something here. There was a mistake in the denominator. You have 2x squared plus 2x, 2x squared plus 2x. And then this should be minus x squared plus 1. Minus x squared plus 1. And that changes this very final numerator, this very final denominator. It changes it to x squared plus 2x minus 1, which factors, this denominator factors as x. This is x. This is plus 1. X plus 1 quantity squared. So there's your very final answer. Simplified. There's no common factors to cancel. Let's write it up here. No common factors. And we've left it in, here this is left in factored form. If they want it in factored form, then you leave it in factored form.